Hey, awesome people. Have you ever really thought about numbers? Not just one, two, three, but what is a number? What if I told you that the numbers you learned in school are just the tip of a cosmic iceberg, and humanity's journey with numbers is one of the most incredible stories of discovery, controversy, and pure genius? Today, we're diving deep into the mind-bending evolution of numbers, from simple counting to concepts so wild they practically break your brain, and yet they underpin our entire modern world. Get ready, because numbers are about to get way more interesting. So, let's go back to basics. Our story begins with natural numbers. 1, 2, 3, and so on. We've been counting since pretty much forever. Think about the Ishango bone from over 20,000 years ago. Early humans using tally marks to track stuff. These numbers were purely utilitarian, for counting possessions, trading, building. Simple, right? But then, things got complicated fast. Next up, zero and negative numbers. Imagine a world without zero. It started as a placeholder in places like ancient Babylon and among the Maya. But it was in India, around the 7th century, that zero became a number in its own right, thanks to mathematicians like Brahmagupta. And negative numbers? Ancient Chinese mathematicians used them for debts. But in Europe, for centuries, they were seen as fictitious or absurd. Why? Because how do you physically represent minus 3 apples? It just didn't make intuitive sense. But guess what? They made subtraction universally possible, and eventually, their utility won over skepticism. Then came rational numbers or fractions. Need to share a pie? Measure half a field? Fractions emerged naturally from the need to divide and express parts of a whole. Babylonians, Egyptians, they all used them. They gave us division, and they fill a lot of the number line. But here's where things get really interesting and controversial. Enter the irrational numbers. Picture this, ancient Greece, the Pythagoreans. They believed all is number, meaning everything could be expressed as ratios of integers, harmony, order. Then, legend says, Hippasus of Metapontum discovered something shocking. The diagonal of a unit square, which is the square root of 2, cannot be expressed as a fraction. This was a full-blown mathematical and philosophical crisis. It broke their entire worldview. But this led to a deeper understanding of continuous magnitudes, giving us things like pi and Euler's number. Finally, the real numbers emerged, completing the number line, filling ALL the gaps, giving us a continuous spectrum perfect for calculus, physics, and modeling, anything that's continuously changing, like time or temperature. Now, hold on to your hats, because we're stepping OFF the number line and into entirely new dimensions. What if you needed to solve an equation like x squared equals negative 1? For centuries, this was considered impossible, until the 16th century, when Italian mathematicians like Cardano and Bombelli encountered the square roots of negative numbers while solving cubic equations. They were imaginary, useless, mental torture, or so people thought. Even Descartes coined the term imaginary to highlight their unreal nature. But then, giants like Euler and de Moivre showed how incredibly powerful these complex numbers were, simplifying trigonometry and giving us one of the most beautiful equations in math, Euler's identity. Take a moment to appreciate it. E to the I pi plus 1 equals 0. It connects 5 fundamental constants in one elegant statement. And imaginary numbers, they are anything but. Complex numbers are absolutely indispensable. From quantum mechanics, where they describe the very fabric of reality, to electrical engineering, signal processing, computer graphics, and even fractals like the Mandelbrot set. They're so real. Engineers even call eyes bitch to avoid confusing it with electrical current. Their utility totally eclipsed any initial intuitive discomfort, and it didn't stop there. The success of complex numbers sparked a question. Could we go even further? Could we have 3D numbers or 4D? In 1843, the brilliant William Rowan Hamilton had a breakthrough, literally carving it into a bridge. He discovered quaternions. These are 4-dimensional numbers. But there was a catch. To make them work, Hamilton had to sacrifice something fundamental, the commutative property of multiplication, meaning A times B is not always B times A. This was revolutionary and a bit shocking. For a while, they competed with vector analysis, and for many applications, vectors won. But Quaternions made a massive comeback, especially in 2D computer graphics, robotics, and aerospace. Why? Because they're brilliant at representing 3D rotations, avoiding nasty problems like gimbal lock, and being super efficient for animations and real-time simulations. Your favorite video game or CGI movie probably uses them. And the journey continues. Following Quaternions, mathematicians like Arthur Cayley discovered octonions, eight-dimensional numbers that even lose the associative property of multiplication, meaning A times B, then times C, isn't always the same as A times, then B times C. This progressive loss of properties is a profound insight into mathematical generalization. Beyond these, we have p-adic numbers, hyperreal numbers, surreal numbers, cardinal, and ordinal numbers in set theory. Today, numbers aren't just about counting or measuring, they're often abstract. We've moved from how many to what are the rules of this system. So, what's the big takeaway from this wild ride? It's a testament to humanity's relentless quest for deeper understanding. Each expansion of the number system, from zero to complex numbers to quaternions, was a revolutionary act. It was often met with skepticism because it challenged intuition. But time and again, the immense utility of these new concepts in solving real-world problems, from balancing ledgers to modeling quantum particles, won out. Mathematics isn't just a collection of facts. It's a living, breathing language that allows us to describe, predict, and ultimately build our universe. These unreal numbers are literally the foundation of our modern technological world, shaping everything from your phone's signal to the animation in your favorite movie. It's a blend of raw utility, profound abstraction, and undeniable beauty. The journey of numbers is far from over. As our understanding of the universe deepens, so too will our mathematical language evolve. It's a continuous dance between what we perceive intuitively and what powerful new abstractions can reveal. Which part of this number journey blew your mind the most? Let us know in the comments below. And if you love this deep dive, don't forget to like this video, share it with your curious friends, and subscribe to our channel for more mind-expanding content.